Okay, so we're going to go back to a problem that we started the last time we were together, and it was problem 224. So if I go to page 36, okay, and I look at problem 224, it says determine the resultant of the three forces of problem 216. So if I go back a page and I go to where problem 216 is right here, there are one, two, three forces. Okay. So what we want to do is we want to find the one force, the resultant, that would replace these three forces that share that origin there. Now, we started this the last time we were together. Okay. We determined the components of each one of these forces already. So, as you probably recall, we drew all of the forces on the X and Y axis. So we had F1, which was 800 newtons going up and to the right, F2, which was 408 newtons going down and to the right, and then F3, which was 424 newtons going down and to the left. And then we used the distances that were given in the problem to calculate each one of the angles that they were at. And then we went ahead and we already calculated the X and the Y, starting with the Y here, components for each one of those forces. Okay. So what we've done is kind of the start work for this problem. And now we want to take it further using those rectangular coordinates or those rectangular components to solve for the resultant. Okay. So all we need to add here for our next step is we want to add our convention. So we want to put our convention in the upper right-hand corner. I'm going to call this step number 1 diagram. I'm going to call this step number 2 components. Okay. And then we added the components last time. So we went through and we figured out F1X, F1Y, F2X, F2Y. And then on the next page here, I have F3X and F3Y. And now that we have everything along the X and Y axis and we have all the magnitudes figured out, we're now ready to sum our forces along each one of those axes to find the resultants in the X and Y component or the resultant X and Y components. Okay. So step number 3 after our components is going to be summing the forces in the X direction is equal to our resultant X component. Okay. Now we're going to go back to our original diagram, and this is where we're going to look. Since we're summing our forces in the X direction, we're only looking on that horizontal or X axis, okay? So notice that we have a positive F1X, a positive F2X, and a negative F3X, okay? So right below here on the left-hand side, we're going to say F1X plus F2X minus F3X. And again, the positives are because F1X and F2X are pointing to the right. Negative F3X because it's pointing to the left, right? And we're going to set that equal to the resultant X component. And now we're going to put our numbers in. So we're going to look. F1X, its magnitude is 639.7 newtons. 639.7 newtons. Plus F2X, mine is down here, 192.2 newtons. Minus F3X, which is at the top here, 224.1 newtons. Okay. And now that's all the forces on the left-hand side here with their units, and I'm going to set that equal to the resultant X component. So now I can add and subtract to find the value. So your resultant x component is 607.8. I'm sorry, Josiah, you said F2x 192.2. F2x. That's what I got. I can double check. Did anybody else get a different value? 61.9 cosine. Nope, I get 192.2. So if I look back here, this is the cosine of 60. I must have wrote it down wrong. That's okay. So as long as you have cosine of 61.9 and then it's 408 newtons. Yeah, 192.2. Yeah, it's okay. So do you get 607.8 newtons for your resultant x? Yeah. Okay. And then now we want to sum our forces in the y direction to get that resultant y component. Okay. So sum our forces in the y equals ry. Go back over here. We're going to have a positive F1y, a negative F2y, a negative F3y. And then we're going to set that equal to resultant y component. And then now we're going to put our values in. So I've got 480.3 newtons for F1y minus F2y. I have 359.9 newtons. And I've got a minus 360 newtons for my F3y. Okay. It's equal to ry. This time we get a negative 239.6 newtons is equal to my resultant y component. Okay. Do you guys get that same number? Okay, cool. Now, this one has a negative. So according to our convention, in the y direction, our resultant y component is going to point down. Okay, so those positives and negatives as those answers mean something. So now what we're going to do is in our step number 4, we're going to be calculating that resultant. Okay. And we're going to use these two resultant x component and y component to show it. So I know that my x component is going to the right and my y is going down. So I am going to draw an x out here and a y. You know what? I'm going to go more to the left so that I have enough room for my calculations. Okay. So something like that. And yeah, this time we're going to be in the 4th quadrant, if you would. So now I'm going to have, here's my x, my negative y. I'm going to draw 607.8 newtons. Make sure you add your units and label. And then along the y-axis, something like this is going to be our ry is equal to, do not put a negative in front of the 239.6 when you draw it here. The arrowhead pointing down is the negative. Does that make sense to everybody? So don't put a negative in front here. So this is going to be 239.6 newtons, and that the arrowhead is going down is going to represent that negative value. Okay. So those are our components. Now through the endpoint of our y, I'm going to put a horizontal. Through the endpoint of our x, we're going to put a vertical. And then I'm going to start my resultant back at my origin, and its tip is going to go to that intersection I just created. And then I'm going to label this my resultant. Okay. Make sure you have arrowheads on the ends of each one of these vectors. And then we're also going to identify our theta coming from the x-axis. Could you do it from the y? But most often, like I said, you're going to see it most often from the x. Okay, so we need to calculate the magnitude of our resultant and that angle theta. Okay, so resultant is going to be equal to the square root of our x squared plus our y squared, right? Now we're going to put our values in. So it's going to be the square root of 607.8 newtons squared. Units have to go in underneath the radical, plus 239.6 newtons squared all underneath. Now, you could put the negative in front of the 239, but it's going to square, so it's going to become positive anyway. Okay. And now our magnitude of our resultant you get 239.8 newtons. I only did it once. I didn't check. Did you know you didn't get the same number? Oh, shoots. 607.8. Square that, 230. Oh, yeah, that's not going to be right. I can see that already. I'm in 239.6 squared plus square root. How about 653? Does that sound right? 653.3. There we go. So that's our magnitude. You don't have to put this in there. I'm just identifying. Remember, we need two things to fully define both magnitude and direction. So this is the magnitude. And then our direction is going to be arrowhead plus angle. Okay. So I'm going to use tangent again. Tan theta is going to be r y over r x. And I'm just going to put it equal to over, I'll put it underneath. My ry is 239.6 newtons, and my rx is 607.8 newtons. Newtons cancel. And my theta you get 21.5. Yeah. I don't have the answer in front of me. There we go. You have to draw your diagram here of the resultant X and Y components and then of your resultant. And then when you get your values here, I need to see R and R, theta, theta, okay? And then units appropriate as well. So again, for this problem, first step was creating our diagram, showing our components, identifying our convention, okay? Then calculating anything we needed to. The calculations here on this side, these were the individual angles because this particular problem actually gave us distances or the slope of the lines, if you would. So we needed to calculate the individual angles. So that's what we did first. And then we calculated using those angles, the components of each one of those forces, the X and Y's. Once we got those, that's where we continued on today. We summed our forces in the X to get that resultant X component, sum the forces in the Y to get the resultant Y component. And then we use those to find the resultant magnitude and direction. So now this force could replace those three forces, those three separate forces, and have the same net effect on that bolt. Okay. Any questions? All right. Now that is the last practice problem that you have to hand in. Okay. So I'm going to stop our recording